Well, we've reverted back to the microphones without the preamplifier, and we'll just have to put up with the low volume, which I'll just have to boost on the mixing stage instead of reducing on the mixing stage, and we'll dig out a different preamplifier in due course. So I just don't have anything that's 3.5mm jack plugs, and this video mixer has got 3.5mm jack plugs, and the only thing I've ever seen with 3.5mm jack plugs are cheap transistor radios and cassette recorders. Everything here is XLR or 6.3mm or 1/4 inch. So I don't get that, but there you are. I'm not. Perhaps it isn't trendy to have XLRs anymore. So I may as well undo a new microphone. I may as well undo a new power lead, because I thought we'll do my Radiomobile 202, which I bought off eBay quite some years ago, probably 10 years ago. It feels a bit heavier than it ought to, and I hope that isn't a warning sign that there's things inside that there shouldn't be. Perhaps there's just some lead weights. The Radiomobile 202 you'll recognise as the Cybernet 3000 in disguise, and also the same as the Ford Roadmaster. I think it's the 505. It's got some pitting of corrosion on there. I don't really care. And on the back it has a sticker saying 86, and Mark's put that on, therefore telling us it doesn't actually work. So won't have undone the side bobble. Let's hope, fingers crossed, that it isn't full of dodgy things. Can't get that screw out. Can't get that screw out. Time for the bigger screwdriver. Ugh. I don't know, that seal doesn't look broken. Do you know what? No, the seals aren't broken. Oh. And there's the doorbell, so another delivery of parts, no doubt. Oh, it's a delivery of stuff from the ham radio CB wholesaler. Now, where did I put that screwdriver there? Some of which is to do our van, because we're kitting out an old van so we can use it as a base station, so we can do some easy terrain range tests, which we can't do from here. First of all, we've got to prove that it works as the van works as a base station with exactly the same aerials we've got here, which is the Amtron 99. I'm not saying that's fantastic or anything, but it's an average aerial, and I want to replicate what we do here with the van. So I want to be able to sit in the van in the car park here, and I want to get exactly the same results to scratchy corner, etc., as I took the wrong screws out there, as we currently do from here. So that'll be our first van test. We're just about there, just got to put a bench in there. Right, well, it's never been got at, never been gone inside. It's even got a slight smell of new radio. I will. No, I won't. I'll leave that. So, power lead. That's interesting. Mark said it didn't work, so we wonder what that was. So I've noted high-low powers on the back. Right, switch on the power supply. 13 point... not there, 13.8 when we get there. There we go. Plug that into the test equipment. And I expect it's doing about 3.5 watts like they usually do out of the box. It might be 38 years old, but it's never been touched, has it? So let's push on, is it? No display. Aha. So no display when you're on channel 9. Channel 20. Tone to high, RF gain to full, and we need better plug in our extension speaker. Bit of a dirty volume controller. There's actually no transmit. And my ammeter is remaining at 300 milliamps. So it's not that there's something not there, like the high-low power switch, for example, or the switching. There's definitely no transmit. So we'll start. I got a comment on one of the videos. I know the recent ones, audio's been lousy, about they couldn't watch the video because of the 1 kHz tone from the signal generator. Oh well, that's how it is in electronics workshop. I'm not altering that for videos. If the signal generator I think needs to be on, then the signal generator needs to be on. You find that when you're working with a 1 kHz tone on all day, that you kind of notch it out of your brain. You don't actually hear it. So that's life in an electronics workshop. Right. So I'll connect my negative pro to power, negative, probably. And let's look at the VCO. It's the far side of resistor 4. Better get the instructions, because even having done this for 40 years I can't remember. So it's channel 40. Right, so it's channel 40 and we're looking for 4 volts. in receive. I've now lost the positive prod. There we are. Aha! Well, that's interesting. It certainly shouldn't be up there. So it looks to me like we've got something wrong with the phase lock loop, because it looks to me like we're not transmitting and we're not receiving. I ought to have just put the signal generator on, and then I'd have discovered that it isn't receiving either. So we'll just quickly go to. I nearly did the AKD 2 meter ham radio set. I know I did the AKD 4 meter one. But I didn't want to do two amateur radio items when this isn't an amateur radio channel that close together. Well, that's interesting. So we've got a lock point with the I wonder if that's a false lock point then. No, it's a false lock point, definitely. So we've got a fault with the VCO. Right, well, we'd better start looking whether the phase lock loop chip has got a voltage to it. So it's pin number . part of the fault finding, what I'm going to do is I've switched it to channel 9. And what channel 9 does is it addresses one of the pins directly on the phase lock loop chip. So it eliminates all this part of the circuit. So if all that was broken, the radio will still work on channel 9. And one of the ideas behind this is that if you had an accident in the car and the front of the radio was damaged, the radio will automatically, if it gets the wrong BCD code, it will switch to channel 9, assuming an emergency, which is really helpful if there's nobody there or there's bucket mouths when you do get there. But the thought from Sanyo was good. And I seem to recall the Toshiba TC9119 used in Uniden sets has a similar trick up its sleeve. So I'm just going to see whether we can get channel 9 to lock. I'll do this on transmit first. And the answer is no. Just to help me here, I'm going to use the Realistic 1005 handheld manual, because it's got the pinouts for the chips in it. So what we're going to do, apart from turn the volume down, is see whether the crystal reference oscillator is running. Now, the oscilloscopes on this bench only go up to 10 megs, they're just there for audio. So normally diagnostic things would be done on a different bench, but I don't have video equipment and I'm part of the way through this, so we will bring a portable oscilloscope, which is here. If I just move the camera across slightly, so what I'm looking for is to check whether the 10.24 reference is running. So let's have a look. That should be that pin there, and there we have, it says there 10.2396. so that's fine, done. Well, I've checked the power's getting to the chip, I've checked that the reference oscillator's running, it is, and I'm not getting anything on channel 9, so I think the chip is faulty. So we'll put the little portable oscilloscope down, and I think it's time to just change the IC. Now, first of all, I'm just going to make sure that it hasn't suddenly started working. Now, I just think the first thing to do is to change the phase lock loop chip. So that's exactly what I will do. So I'll stop the video and get over to the stores department and pull out an LC7137. Okay, roll on the next day, and I've changed the phase lock loop chip, and we now have the VCO. So in this case it was the phase lock loop chip for some unknown reason. So I think I've set it up, but let's just check. Far end of resistor 4. We want 4 volts on channel 40, and then in transmit we want 4 volts also on channel 40, and then on channel 1 we need to check it's still in lock. It's in lock on transmit at 2.3 volts, and it's in lock at receive at 2.28 volts. I did replace this from a scrap chassis because the core was a bit dodgy on the, despite it being a sealed radio, as you know. So just looking at this, 1.8 to 2.5 volts on channel 1. So we've done it, we're there. So now we just go through the normal tune-up procedure. Just drop the volume off so you're not hissing at it. Right, so we'll take away the meter. Possibly just zoom in a fraction and select picture in picture when I can find it. Not that quick. Okay, so we're going to go down these. It's 4, 2, 3 and 4. That's 2, 3 and 4. So we're looking for 4 watts. At the moment we've got 3, so 5 watts is there, 4 watts is there. So we're at 3. So if I switch it to the 3 watt scale, we've got full scale deflection. So we'll just see whether we can pop that up a bit. Usually can with Cybernet sets. Because this is a sealed radio, this is going to be more or less as it's been set up, and they're always set up low, as you know, so that if they're batch tested at the docks, they don't get the whole batch rejected. The dealer's supposed to do a tune-up, but very few dealers seem to. Right, so we're looking at 4, 8 and 9. 4, 8 and 9. So maximum on 4. Interesting. I can't move it. That's handy, isn't it? I'll just go and get a different tool. Oh, trips over scrap chassis on the floor. Of course, where you keep them. So what we got here? So we'll use that one today. And that's just brought us up to a shade from 4. go through them again. 4.5, 4.6. Okay, and now what we do to set it right, rotate coil L4 to obtain 4.4 watts. So we'll just do that. Sorry, it's clockwise for 4.4. There we are, clockwise for 4.4, and L9 anti-clockwise, if I remember. Supposed to be 3.8 watts, but we're not trying to ship the radio, so we'll have 4 watts. And there we have 4 watts spot on. Well, that's an improvement. So the next thing to do is let's see whether the radio's on frequency. So just move this across. Oops, wrong one, wrong camera. So the frequency counter, we're looking for 2779125 on channel 20, and we've got 27. Oh, good grief, I've gone and tuned it up on channel 1. So now we have to start again. What a silly billy. Right, we'll get these to peak these to maximum again. This is important. Clockwise for 4.4, anti-clockwise for what they say is 3.8, which is actually 4. So I'm just going to check we've got similar power on channel 1, 4 watts on channel 1, and 4 watts on channel 40. If you don't get it done on channel 20, like I just didn't do, then it's not going to track right across the 40 channels. There's nothing worse than a radio there's 2 channels. Sorry, there's 2 watts on channel 1 and 5 watts on channel 40. Right, back to what we were doing, we're checking the frequency. So 2779125 is dropped with age, as is to be expected. So the crystal trimmer is the red one there. (2779127) will do me nicely. It's just slightly above, and then it can drop as the set gets older once again. Okay, so 4 watts is there, and now on low power, what have we got? Apart from a dirty switch. No, the answer's not a lot. Perhaps we've got a dirty preset. We have, and there we are. 0.4 watts on low power. So high power, 4 watts, and there we have it. Now what we want to do is to make sure that the meter on the front says something like, well, it's lit all 4 up, you know, for what it's worth. So we'll just adjust that so that it just lights all 4 up. There we go. just lighting all 4 up, and when I switch to low power, I'm hoping it lights something like 1 up. Wallow. Oh, hello. Is that what it does? Right, so that's that set. Now we come to deviation. We've got a new box. Instead of using the normal oscillator, I've been very kindly sent one. It's arrived in the post yesterday. Chris from All the Gear No Idea has made me a Wahlowmatic, and he's just so kind of him to do this. We'll switch it on, and it's got various tones in it, including me saying Wallow. But at the moment we've got the 1 kilohertz tone which we need. So we'll set the deviation. Which, as you can see, is just slightly there. It should be 2.2-ish. So just set that. I've gone and pressed the wrong button because it's got other features. Wallow. So let's see. That's just slightly over the top. I have to get used to a new instrument. Wallow. Excellent. And it also says useful phrases. Wallow, 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 wallow. Look, no hands. Thanks, Chris. That's a fantastic piece of kit. Everybody should have one. It has some other useful phrases like scratchy corner, and if I'll just switch it on and show you. Mr. Chippy, yeah, Roger, Tango 20 on receiving, and I'm sure you're going shopping. Roger, got you at the end of the lane. Roger, got you at Ancaster service station, and I'm sure you're going shopping. Roger, got you at Ancaster. And then we can sequence through to the next, which is the tone, white noise, his theme tune, Wallow, Wallow, and Wallow. Wallow, Wallow. Isn't that fantastic? He's my bestest friend at the moment. Right. Well, that's set that up. That makes it easier. Don't have to get the other oscillator out. That's easy to work. After all that excitement, where were we? We were going to move on to the receiver. Okay, what's happening here? So we'll put the oscilloscope on. We'll put the cyanide meter on. We'll move this camera onto the oscilloscope. Wrong button. And actually we can use the other oscilloscope for audio. I think we're probably better off doing so. Oh, we're not doing transmitted audio, we're doing received audio. I'm forgetting what we're doing. Now, why does this sound lousy? Because the earth wires come off. So we'll just it's time to fix our own equipment. Right, now we're back to the normality. S9 on the meter, on the signal generator, S9 equivalent, 100 microvolts, and we'll get that for maximum. So maximum recovered audio is for the detector T12, and T12, I'll just move the camera so we can see it, is here in the naughty corner. It's just about spot on. So now the plan is to tune the radio front end. So we'll move the other camera onto the Cybernet Beta. So we start here, and what we're going to do is hope to get, make sure we're actually on. Yeah, we've got, it's about 4 decibels, and at the moment we're listening to 0.3 of a microvolt. Tell you what, that's an improvement. There we are. It's set. I'll just tickle up these IF ones. That's about it. Okay, so for 20 dB Cybernet, we'll get the notebook out. So we have got 1.8. Right, we'll now move on to 12 dB Cybernet, which is the normal industry standard one. 0.69. And for 10 decibel Cybernet, 0.52. Okay, that's fine. So while we're playing with the signal generation, we'll do the S meter. It's reading 3 out of 4 bars, which is probably exactly where it needs to be honest. That is. So going up a bit gives us. So I'm now at about +10. It's lit the 4th one up, but we don't need to adjust that. But if we did need to adjust it, then it is the preset just there. Now we'll do the squelch. It's alright when they're not being messed with. So I've set the signal generator to 3 microvolts, sorry 0.3, and we'll now put the squelch to minimum threshold. And the radio's come on to fight me, and it's coming in at 0.41 microvolts and it's leaving at 0.33 microvolts. So we'll turn the squelch on the radio to full. I'll move the camera across so you can see the controls on the test set, which are there somewhere. So, full squelch on the radio, 1 microvolt on the signal generator, 3 microvolts, 10 microvolts, 30 microvolts. I want it to be 100 microvolts, so I want the squelch a bit coarser than it is. And that's the preset there. Now it's coming in at S9, which is exactly where I want it. So now we're going to check the bottom end again. So I'll switch the signal generator off, turn the squelch down, set threshold, oops, not quite, and switch the signal generator back on, and let's see where it is now. So it's coming in 0.38 of a microvolt, it's going out 0.34 of a microvolt, so that's fine, that's set beautifully. Just make sure there's no noisy controls. It's a bit noisy, isn't it? Oh, it's one we can actually get to. Right, we'll put it back together. Right, so let's put it on the air. Nineteen, Roger. Right, well that's it. We're done. I'm not going to do anything to the case. It tells a bit of a story. I actually think it came in a batch of stuff that I was given by one of the farmers who comes to one of my churches. So that was very kind of him. So yeah, I mean genuine fault. So for some reason the phase lock loop chip had gone up the spout. Of course, that's not a cheap repair because those chips, if you can get them, are between 14 and 18 pounds, and the ones that are coming through now have got very tarnished legs, and it takes a lot of time to clean them up into such a way that we can actually solder them. And of course they're going to be tarnished legs because they're 40 years old. Anybody offering you chips would look like they've just come out of the factory are probably fakes, and we've all suffered from that. So we'll do an on-the-air test later. I've pushed this through on a Saturday because I wanted this out of the way because I want to do an on-the-air test with the 4-meter amateur radio set that we were tuning the other day. I've got a friend 16 miles away who can't talk to me unless I put ridiculous amounts of power on. So he can't hear me on 25 watts. He can only hear me when I'm doing 100 watts. And that's ridiculous. So I'm going to send Mr. Chippy out with the 4-meter radio in the car and see whether he can hear me in the car, and then we can find out what the problem is with our amateur radio friends setup. So that's what the crack is. Without checking up the licensing rules, I seem to recall I'm entitled to 400 watts on that band, but I would just check with the licensing before I do the on-the-air test tonight. We're going to do it in 2 ways. We're going to do it at 5 watts and we're going to do it at 25 watts. But as far as CB goes, we're doing this tonight, and we'll do an on-the-air test, and no doubt it'll work great, because they usually do. So thank you for watching the Radiomobile CB202 from 1981.